Good morning, everybody, and thank you so much for joining us for today's event. I'm Jo Evans, and I'm the Director of Strategy and Performance at the Advanced Propulsion Centre. I am absolutely delighted to say that we have got a record number of people on the call joining us today from all over the UK and Europe. Now, I am personally really excited and looking forward to today's event. I'm excited to hear from some of our fantastic industry speakers and our great APC team as well. The roadmaps play such an important part in our ability to understand the changing nature of the industry and the ecosystem, and apply this to the way that we develop and design our solutions and technology that will really help to pave the way to a net zero world. In today's session, we're going to be diving into the recently released Automotive Council product and technology roadmaps, as well as starting to explore some of the details within those roadmaps. We'll be joined by a panel of industry experts who are going to share their automotive industry perspective on some of the key trends, on some of the high probability technologies, and also some of the future innovation steps. Now, hopefully this will give you all a bit of an opportunity and an insight to gain some valuable views into how you as an individual, but how you and your organisation can play a part in harnessing the opportunities as we travel the road to net zero. Now, before I introduce our keynote speaker, we do have a couple of housekeeping items just to review. So very quickly, and hopefully you can see this first slide. Firstly, all of your cameras and microphones have been disabled. Now, if you do have any technical issues, I can see that some of you have already started to use the chat function. So any technical issues, drop a quick note into there to one of our team. Somebody will pick it up and help you answer some of those supporting issues. Now, we do have an opportunity at the end of the panel session for a few questions, although I am conscious that we have a full packed and very rich agenda. There is a Q&A box at the bottom of your screen. You should just be able to see it, little square box with Q&A underneath it. Please click on that box. It'll open a separate tab. Drop any of the questions that you've got that you'd like to ask any of our panelists or our keynote as you go through the session. Now, we're going to have some of our team online who are going to try and answer some of those questions as we're going through the day. Anything that we don't get the opportunity to speak through as a sort of roundup at the end of the session, we will share with you through some feedback after the event. Now, speaking of feedback, there is a very short SurveyMonkey survey that we'd really like to ask you to take some time to just fill in, just a couple of minutes, just to give us any feedback on the event. It's a new style and new format for us, so anything that you have is much appreciated, so that we can organise better in the future. Now, I've mentioned that there is a chat function. Please feel free to use it. Please use it as a chat function to the whole group, or you can chat privately by using the drop-down button on the side. And then finally, before we get started, we are going to be recording today's webinar, and it will be available very shortly on the APC website, hopefully through tomorrow. And of course, you'll get a notification by email, and we'll start sharing on social media. Now, without further ado, I am absolutely delighted to welcome our keynote speaker, Chair of the Automotive Council R&D Working Group, amongst many, many other things, and curator of the very first iteration of the roadmaps, Neville Jackson.
Thanks, Jo. So I'm just going to give a very short overview of the purpose, use and limitations of technology roadmaps in general before we go through the APC roadmaps in a bit more detail. So to start with, a little bit about context. As we're all aware, there's an accelerating rate of change in the auto industry. Some say we're going to see more change over the next 10 years than we've seen in the last 50, really driven by electrification, connectivity and automation, and digitalization, just to name but three. To address those challenges, there are a plethora of new technologies. Obviously, we can't invest in all of them. No one company has the resources to do that. So which should we invest in to be successful? So the objective or purpose of the roadmap is to try and find the most attractive path to meet our future goals. It can also support development of an R&D agenda. It's not an R&D agenda in itself, and I'll talk about that later. What we've produced recently are consensus roadmaps. That's where groups of stakeholders come together to provide a common view. And they're particularly useful in identifying specific or common industry challenges, communicating this to other stakeholders, and to find collaborative opportunities. As you're all aware, the UK Automotive Council has been very active in producing technology roadmaps, particularly consensus roadmaps, the first of which were published in 2009. These have been very widely used and disseminated, not just in the UK, but outside as well. We have also produced regular updates and additions, and APC are now taking the lead in taking those things forward. So what makes a useful roadmap in my view? First of all, it's very important that roadmaps feature future targets and drivers. That covers market, consumer requirements, and the societal demands placed upon us. And wherever possible, they should have SMART targets. That's quantitative, not just qualitative. So we know specific performance, specific requirements, and any regulatory or other requirements that we need to achieve. It also shows the technology changes or additions required to meet those targets and drivers, and the most likely pathways to be adopted by the mass or volume market. It doesn't show all pathways, it shows the consensus most likely pathway to get from A to B, which is what a roadmap is all about. And it shows why a specific new technology or approach is likely to be needed, what is the most likely technology to address that, and when it should be introduced to the mass market. So just to finish off, a few caveats perhaps about technology roadmaps in general. First of all, they're only predictions based on current knowledge. So new knowledge or discoveries will mean that the roadmaps must be updated regularly because they have a shelf life. You see a roadmap that's more than 3 or 4 years old, it's probably out of date. So technology roadmaps are not in themselves a list of interesting new technologies or an R&D agenda, and they're a subjective analysis. They do not include an analysis of disruptive technologies. By definition, as we all know, disruptive technologies do not appear on technology roadmaps. So in my view, the road mapping process should also be supported by what we call horizon scanning. So that's to identify disruptors and their potential impact and things that may disrupt that technology roadmap that we've produced. The APC is now taking a role in leading some of that horizon scanning, and you should look at those as well as the technology roadmaps to understand where the future may lie. So that's all I was going to say. Maybe I can hand back to Joe now.
Thank you, Neville. Thanks for just an interesting insight into the introduction of why the roadmaps play such an important part in our future delivery of net zero. Now I want to introduce the APC team. Okay, so these guys have been absolutely instrumental in the design, development and orchestration of the new roadmaps. They are the absolute fountain of all roadmap knowledge. So here to talk you through a very brief introduction of the roadmaps, I'd like to introduce John Regnar, Automotive Trend Strategist, and Bhavik Shah, Roadmap Project Manager.
Thank you. So good morning, everyone. Really delighted to be here. The APC's really looking forward to sharing with you the newly released roadmap narrative reports today with you. So Dave Odeweyemi, Head of Technology Trends at APC, John Regnar, who just got introduced, and myself, Bhavik Shah, we've been working to get these publications ready for release, and that's what you'll be hearing about. So what John and I will take you through is a brief understanding of its content, how you could read it, how you could take advantage of it. We'll go through the product roadmaps and the technology roadmaps in a brief way so that you can take advantage of downloading it, reading them at your leisure, take your time to get the benefits from the insights contained within. Okay, so what we have today to share with you is a live set of 9 reports, 1 per each high-level technology roadmap. So we've got 3 product roadmaps: light duty, heavy goods and off-highway, and bus and coach. Each one we've now compiled at the back of it a piece of material that provides commentary, context to the assumptions of the high-level roadmaps. We've even got 6 further technology roadmaps, of which you know the newest one is the fuel cell roadmap, those who've been following the work last year. We had 5 technologies, of which we have now got a further addition to the family. These are all net zero capability roadmaps for us. Net zero takes us all the way, not just from zero tailpipe aspects, but it takes us all the way through LCA. It talks through where the technology needs to be and the full life cycle aspects of it that could come out of it. So these reports have been set out to share insights that industry experts have fed into the roadmaps. John, Dave and I have worked with industry, we've worked with the Automotive Council, BAYS, academia across while developing the roadmap, and all of this is contained in the reports we provide you. We then provide a narrative and context on the future trends, drivers, and technology enablers, very much as Neville says, to give us a much more richer understanding of roadmaps, not just a few aspects of technologies, but where direction of travel is going. And the other aspect we've used this year is a simple call-out style. We want these reports to be easy as reference material and easy read as well. And with about 20 to 25 pages, we hope we've achieved that. So what's in the product roadmaps? I'll take you through the product parts of it, and I'll hand over to John in a moment to take you through the technology ones. So the first part of the structure of the reports is we create in the start very high-level executive summary pages. We create 3 pages on the light duty, 3 on the heavy goods, and 2 for the buses based on the categories of vehicles that are involved. So urban mobility will have a page like this, but I've just pulled out an example of the one from the heavy goods vehicle roadmap. This is on long range and off-highway vehicles. What's specific about this will be on the same page, you'll see at the bottom, the technologies, chevrons and their evolution through to net zero. You'll see the vehicle types in the middle that these represent, so it's all there. And at the top, a simple summarized view of what's happening with the pathways. So this particular part of vehicle sector is very complex. It's demand for energy, how the vehicle use works, the multiplicity in which it needs to operate with different powertrain systems is part of how we vocalize this to help maybe senior leadership structures understand on a single page how this sector is panning out. When you need more detail, the roadmap reports, narrative reports, then take you to another section of the document where with every single bar line on technologies and chevrons, we're giving you an overview of where things are going with this technology. So taking the same example of the long range and off-highway, digging deeper, how is ICE evolving? ICE evolving into the net zero platforms. How is ICE being displaced by battery electric? How is fuel cells emerging already? So both on a timeline perspective and a narrative, fuel cells are already outside of the EU, which is a light green bar before it goes to the solid, already exists. We know fuel cell demonstrator vehicles are there, but we also know truck manufacturing at high volume is capable. And then from 2025, we see how fuel cells might come into this sector, of which battery electric vehicle is also part of that picture. So this could be useful for industrialization strategy, technology experts, modeling or collaborative research as well. Now, coming on to a new element we introduced into the product roadmaps. We created a link between energy vectors and the propulsion technologies. As you can imagine, absolutely useful. We know infrastructure is part of the piece, but the source of the net zero problem is significantly within the fuels or the energy we drive it with, obviously. So with this, we've used a color coding process on the high-level roadmaps that we published last year, but the narrative report gives you the flavor to this. So orange being ICE fuels, green being electricity, blue being hydrogen. What we can do is index along the top, as you can see in urban services, long range, the various technology bars that you saw a moment ago. We can index that against what will drive that as an energy vector. So hybridization is electric and ICE fuels, but ICE will have to migrate to net zero. And we speak through how e-fuels and biofuels become a trajectory forward. Whereas if you go into the middle of it, where you've got the long range off-highway sector, looking at ICE, here we start to see hydrogen itself being a valuable combustion fuel in addition to a separate topic on fuel cells. So the third element on this is the fuel cells, which has hydrogen, which is the obvious PEM aspect. But actually, we also have ICE fuels in there. And that's because solid oxide fuel cells is a very capable technology of delivering these kind of engines for us. With those fuels being decarbonized, solid oxide then can be a net zero capable fuel. And that's why it's got those 2 colors as an example. And finally, giving some context to the trends drivers. So there's regulation aspects, which we cover in brief, but what about the powertrain efficiency on board? So everything that's on this is an example again from the heavy goods vehicle roadmap. It'll be different for light duty. In this case, we're looking at how hydraulics and ancillaries on board are power hungry. They themselves have inefficiencies built into them. They themselves have losses. And therefore we talk about those efficiency gains as a prerequisite. And then later on, and these text boxes are small, not for reading right now, but they'll be on the report for you, is you can see the technology enables as a separate new matter to go with platforms, design of platforms. Where are platforms going? What's happening with CAV? We'll see more about CAV technologies on signposted as Zenzig's roadmap. Digitalization across this from a design perspective, manufacturing, and how they operate as well. And you'll hear more about the ID Digitalization Roadmap today, and that links into this. And then there's fleet management system efficiency. So the perspective is to give a little bit more background to all of the reports in the reports for the high-level summaries that you saw last November at LCV. Okay, I'll hand you over to John to take you through technology roadmaps.
Thanks, Barvik. That was a really good overview of the project roadmaps. So I'm just going to quickly go over the structure of the technology roadmap narrative reports and what people can expect to gain from reading those reports. So, as mentioned at the start by Barvik, there's 6 narrative reports covering each of the strategic technologies that the APC funds. So electrical energy storage, which is batteries, electrical machines, power electronics, thermal propulsion systems, lightweighting, and fuel cells, which is a brand new roadmap for this year. However, before we discuss each one through our expert panelists, I'd just like to sort of talk to readers about what they expect to gain from each of the narrative reports. So I think first and foremost, these reports can offer significant value to companies that work both in the automotive supply chain and very closely with these technologies, but also those wanting to move in to the automotive supply chain as well in these specific technologies. So first of all, these roadmaps provide objective metrics on how technologies are continuously improving. So things like cost targets, power density indicators, efficiency indicators, which really give an insight into how quickly and rapidly technology is evolving. And this gives companies a real sort of objective and consensus-based view on how technology indicators will evolve moving forward. Secondly, the roadmaps break out key technologies into broad technology themes. So for those not familiar with a specific technology, be it batteries or e-machines, these can really aid understanding in key technologies and could aid in what areas your business could potentially focus on if you want to move in to sort of low carbon automotive. And even for those already active in a really specific sort of area of technology, say if you're a cathode or in a cell manufacturer, you can look at what's going on at battery packs or other things. So it gives an opportunity to get really deep into what you're looking at, but also to look at what's going on in other technologies as well, so you can complement your development. And finally, in this iteration of the roadmap, we've really closely linked the product and technology roadmaps together. So when you're reading the technology reports, especially that detailed commentary, it offers insights into technologies that may be suitable for high volume automotive, those that may potentially be suitable for high performance or off highway or heavy goods vehicles. And it really gives that delineation of, okay, this technology, it has a different trajectory and application compared to another one. So this is how the roadmap is structured and the sorts of data and insights you'll get. So it'll start off and you'll see data from the workshops and surveys that we did in the middle of last year. And so these are key qualitative and qualitative insights from the workshops that we run online. Secondly, you'll have a detailed slide and a page on targets and performance indicators. So for the electrification technologies, that will be mapped to power and energy. For fuel cells and thermal propulsion systems, that will be light and heavy duty. And for lightweighting, that will be sort of ambitious and business as usual lightweighting targets. And importantly, these targets, especially for the electrification ones, have sort of specific sort of specs, so that when you're looking and developing these technologies, you can understand what a typical voltage range or power could be for a particular application for high volume automotive. But probably the most important thing of this roadmap is the insights, and these were developed through sort of the workshops that we had and sort of what are the key market trends. And it brings together broad innovation trends, very deep technical insights of what the industry outlook is in sort of the very specific technologies. So just to give you an example, to give a bit of flavour to it. So on the screen here is just an excerpt from the electrical energy storage roadmap, and what you'll see is the development trajectories for cathode materials. And on the screen is the developments for low-cost cathodes and high-energy cathodes. And what it does is go into a lot of detail around sort of the future sort of development trajectories for what's going on for low-cost and high energy, because they both have different applications. And this is a sort of rich data that was developed with industry, but also looking at market trends and understanding what's going to be going on in the next 5, 10, 15 years. And this applies to all of the technology roadmaps. So on the next slide, we'll see the fuel cell roadmap, and it'll give very detailed commentary on fuel cell stacks, for example, and what's going on with bipolar plates, or things for solid oxide fuel cells as well. And again, for thermal propulsion systems, a new addition this year is the inclusion of sustainable net zero fuels. So explaining how fuels and engine technologies will develop moving forward to ensure that we have a net zero sustainable kind of solution for some sectors that are very hard to decarbonise. So again, these technology roadmaps give some really good insight. So that's me and Barvik done for today. Thank you for listening. You can find the product and technology roadmap narrative reports on the website. They're now available to download. And if you've got any further questions, feel free to get in touch with either me, Dave, or Barvik. And thank you for listening.
Brilliant. Thanks, John. Thanks, Barvik. An incredibly interesting journey into the development of the roadmap process. And it's really great to be able to get an understanding of how the roadmaps, not only how they're formulated, but how to read them. And gosh, just how much consensus building and industry knowledge goes into the development of them. Okay, so now I would like to introduce you all to our next session. This is going to provide a series of insights into the individual technology roadmaps, as John just mentioned. We're going to hear from some of our industry experts on the key technologies, and then we're going to have a brief Q&A at the end. So please feel free to use the Q&A box. Please pop any questions in there. Anything that we can answer in the short term, we will do. So I'm absolutely delighted to welcome our first speaker on electrical energy storage, Ulrika Ulissi, battery research engineer from Nissan. Ulrika is an expert in battery technologies, coordinating R&D projects across Europe and focusing on next generation EV automotive technologies. So welcome, thank you so much for joining us. How have you used the Automotive Council roadmaps in Nissan?
Thank you, Jeff, for the introduction and for the good question. To give you a direct answer, we use them extensively. We use them in the past, we use them in the future to basically develop and shape our research themes. We use them to benchmark our own targets, for example, and they also help us identify the key technological trends, I would say. Something that it's both useful for us here in the UK, in Europe, but also for our colleagues in Japan. And I'd like to explain you why. I think here our colleagues in APC really need some praise, because it was a very good piece of work. You know, by engaging, as you mentioned, business, academia, and so on, we got an unbiased summary, I think, which is very, very important. So it's a good reference, which is easy to read and made in a transparent way, basically, which is not easy to find globally, I would say. So it's a very good piece of work.
Oh, great, thank you. And as a high volume OEM, are Nissan exploring sort of alternative battery chemistries in terms of your future projects? And what, I guess, what do you see the biggest trends being in this technology sector?
Okay, that's another good question. Yes, we're exploring different battery chemistries. Let me give a sort of preamble, I would say. So batteries are complex and include a wealth of expertise, to be honest. So it's chemistry, but also engineering. And I think it's important to consider what we call key performance indicators, something that I think Neville touched upon very well before. We need to measure basically the performance. In batteries energy storage, we usually need to compromise between for example, power, energy cost, range, lifetime. That's the situation today. For companies like Nissan, the only KPI where you really cannot compromise, and for most OEMs, I would say, is safety views. Again, you need to protect the customer. So today, for example, range is less of a concern, I would say. As a trend, I think battery pack cost reduction is something which is becoming more and more important, because basically we need to make EVs affordable for everyone. And the other important, I think, trend today is that we need to eliminate this compromise between, if you want, cost and performance, basically. So that's what we're looking at the future. And that's where we need to identify, technologies which allow us to remove basically this compromise. And one example of a chemistry which is now attracting a lot of interest is solid-state batteries. The other, I think, important thing to consider is around battery life cycles, so CO2 emissions, basically. Because basically, I think we are doing, electrification, net zero, and so on, because the overarching goal is really to reduce our carbon footprint on the planet in the end. So I think all the innovation will be driven by this really society needs to reduce our impact and reduce CO2 emissions. So that's another key driver, I think, and trend.
Oh, great. One last quick question, if I may. You mentioned before the cost. How much cheaper can lithium-ion batteries get? Do you think it's possible to get below $50 per kilowatt hour?
That's
a quick question.
I hope so. I think it's going to be challenging. It will be down to chemistry and raw materials, to be honest. So engineering is a bit the tool we can use to achieve this target. And with the current technology, it's going to be hard because nickel, manganese, cobalt are expensive. So we need to look at next generation cathodes mainly, and we need to put a lot of variables in the equation. So also end-of-life strategies are important to consider, for example.
Brilliant. Okay, thank you. Thank you so much for that introduction, and really illuminating. Anybody, any questions for Ulderico, please just pop them in the Q&A session and we'll get back. So thank you so much for joining us. We're going to move on now onto our next session, and I am delighted to introduce our expert in electrical machines, global technical specialist on traction motors and drives, Alexandros Michailidis, Chief Technical Officer of Marvel EDT. Hi Alex, lovely to see you.
Good morning, Joe. Thank you for having me on.
Thanks. So electric machines have been with us for a long time. Why so much innovation now, do you think?
Yeah, and there's an expression a lot of the time that says there's nothing new in electrical machines, huh? But now in automotive, I mean, when you look at innovation, it's always driven by essentially competition. And within the automotive sector, there's a number of demanding requirements, and I think this makes the sector very fertile for innovation. You look at the use cases that we see in automotive, in motorsport, in aerospace, and all these use cases that are actually driving very novel solutions, in my view, year after year, and they deliver, machines that have very high transient torque and power density figures. You've only got to compare standard industrial electrical machine to what you get today in a high-end automotive application, and you will see the differences in performance, and you will see the innovations. I think the other aspect of it, we're actually exploiting continuously new innovations in materials and manufacturing methodologies. Okay, the basic ingredients are the same, so we still got the iron and the copper, and that stayed the same over the last few years. But when you take these materials, for example, if you take permanent magnets, we started off with remnant densities of 0.4, and now we are at 1.4. So there's been a significant increase in the performance of permanent magnets, and that's affected the performance of the machines. But there's also been a change in the way that you can actually form permanent magnets and shape them, and that has led to innovations in the topology of the rotors, and more innovation in the topology of the machines. So there's a lot of that. There's 3D machines that are coming on because they're fueled by innovations in powdered ion technologies. And if you look at the copper, another traditional material, when you look at today, the kind of windings that you can get manufactured, and I'm thinking, for example, compressed stranded wires, a hairpin, all these again are fueling very high current torque densities, power densities in the machine. So there's even more to look forward to, I think. I'll mention a couple of things like on the material side, maybe mention superconductivity as one thing that we could be looking forward to in the future. And on the manufacturing side, there's a lot of work around on additive manufacturing, which I think is going to impact the technology going forward.
Oh, wonderful, thank you. And how do you think the roadmaps play a part in that development moving forward?
Well, the roadmaps, I mean, they're very useful. First of all, I mean, they're put together by an interaction of experts from OEMs and tier ones, and they give the industry a very useful steer on what's considered to be present state of the art, what's considered to be future state of the art, and what are the requirements, where do we need to get to in order to better the technologies that we have around us. So they give a very good guidance of what we should be going after. Another thing that I find very useful is that they bring together different companies that have common goals really, and get them to work together through the APC.
Oh, wonderful, thank you. And just one final question, if I may, is there a particular motor topology or type that you think is going to become the sort of optimal standard across applications?
I don't expect so. Again, looking at the technology that will prevail, that will depend on the requirements that the OEMs will have, and these requirements are multifaceted. You have requirements such as efficiency, performance density, cost, and then all of these. You can also couple these to what the use cases are. What are the driving cycles that these machines are going to be requested to go through? And when you look at all that together, that final choice of a topology or a machine is going to rest on the weight that the OEMs apportion to these different requirements, and how these requirements are addressed by different technologies. I would actually say that going forward, we're actually going to see, even more motor topologies that they're optimized to address specific attributes that the OEMs are putting forward there. And that's going to be fueled by these advances in manufacturing, in assembly techniques, and in multi-physics modeling, which today is getting a good hold on us as well. Brilliant.
Thank you so much for sharing your perspectives. We're going to move on now to our power electronics session. Thanks, Alex. Much appreciated. So, yeah, our next session focuses on power electronics, and joining us today all the way from Munich is our industry expert in automotive high volume, high performance power electronics, technical project leader from BMW, David Bock.
Hi, thanks, Joe.
How are you doing?
Not too bad, thank you very much.
Jolly good, thank you. Again, just a very brief question to you to start with. How have BMW used the automotive roadmaps?
So for us, it's everybody's talking about benchmarks, and of course that's important for us to have a benchmark. We were part of that process, and I was very glad to be part of that process and actually drive the APC, because we want to be quite aggressive on it. We're a premium provider, so we always consider that we're at the top end of that benchmark. So I think it was important for us to be part of that process, to push it, and actually really challenge the industry to move that forward.
Oh, fantastic, thank you. And the roadmaps acknowledge silicon carbide that there's reached the sort of market earlier by sort of performance vehicles. Do you see silicon carbide trickling down into high volume passenger cars?
I think the advantage that the market has is the premium OEMs are taking this because we need it for our vehicles. We tend to have the higher performance, larger vehicles, and we also have the CO2 targets. So we have this new WLTP, sorry, I'm using the German. we have the WLTP cycle that we're all measured against now. So we're pushing that, and we know that silicon carbide changing the voltages is a mechanism to get to it. So we're doing the investment now. We're putting those technologies in, and for sure, once the volumes get there, the cost of those parts comes down, and it will naturally trickle down to the other markets. But at the same time, we're not sitting on our hands. So at the same time we're bringing those products to market, we're looking at what's the next emerging technology to make sure we stay on the roadmap.
Great. So silicon carbide gained an early lead on sort of gallium nitride as the new sort of semiconductor material. Silicon carbide and gallium nitride, are they complementary, or do you see there being sort of some vicious rivalry?
I think it's horses for courses. Today, silicon carbide is a very good match for the voltages and the current requirements we have. It's just the correct part for the emerging voltage classes and the power classes. GaN is still very interesting for us. It has other properties. The cost is very attractive for us, and it has other things. It can switch very quickly. So I think maybe you'll see it in the DC-DCs and the charging side, and maybe in the future for neighborhood vehicles or city vehicles, which are smaller, you'll see it coming into inverters. But at the moment, we're focused on the industrialization of the silicon carbide and bringing those technologies into volume production and getting the cost down and getting all of the technical aspects right so that we can make it the best it can be.
And what are the biggest obstacles, sort of certainly for OEMs, in terms of that sort of wide bandgap semiconductors and the sort of power modules specifically in automotive applications?
The biggest challenge we have today is actually the design cycle time, and there's a bit of a misalignment between the cycle time of the emerging technologies and the vehicle cycle time. So normally we have a fairly long sort of 4 to 5 year cycle time. And in this time, the silicon technologies are either not mature enough for us to consider, or we take a big risk. We have to jump on board with one technology and hope that it's still current when we launch the vehicle. So this is our biggest challenge, is actually the cycle times. And one of the things we're doing in our APC program, actually APC 15 at Future BEV, is we're looking to try and mitigate that by standardizing some of the packages so that we are less sensitive on the technology in the package, but we can design a component that uses a standard package. We can do all of our vehicle design, all our inverter design, and then we can allow the silicon providers to put the best technology in that package and fit our design without having to tear everything up and go through the 4 to 5 year cycle.
Oh, fantastic. Thank you, David, and thank you for sharing sort of your interest in insights on the sort of like the complex elements of power electronics, a confusing subject. Thank you.
It's one part in the inverter. There's about 4,000 parts and it's one piece.
Yeah, so it's certainly interesting to recognise how complicated it can all be, and thank you for sharing your sort of views on the roadmaps as well. And we're going to move on to our next session now. David, thank you very much. We're going to move on now to hear from our specialist in thermal propulsion systems, Chair of Powertrain System and Fuels Group at the IMechE, and research advisor across a number of universities. I'm delighted to welcome Steve Sapsford, Managing Director of SCE. How are you doing, Steve? How is everything?
Oh, I'm good, thank you. Lovely day down here.
Fantastic. Not too much snow.
We don't really get snow on the south coast, really.
Brilliant. And I'm going to kick off with a toughie. With a ban of sort of new petrol and diesel car sales in 2030, is this the end for internal combustion engines, or is there light at the end of the tunnel?
Okay, wallop, straight between the eyes. Excellent. No, it's not the end. Firstly, let's just be careful a little bit, because our roadmaps are not just UK, and you know that ban is a UK thing. Other countries are looking at it, but we do need to take a wider view than that. So just a note of caution that this is a wider view than just the UK in the roadmaps. But it is fair to say that, you know, the future role of the internal combustion engine will change. It'll vary by sector, and it'll vary by application. So for range extenders, for example, you might want small, cheap, narrow operating range engines and wide operating range engines for hybrids and plug-ins. The challenges for heavy duty sector, for example, with the energy density requirements, mean that an IC engine will probably last a lot longer in that sector. So it really is a sort of moving feast. So it's very difficult to say that it's ended. And let's not forget, you know, that an engine is a phenomenally successful machine. It's well established, it's very easy to make, and it's very good on its life cycle analysis, the LCA, you know, which is one of the sections that we've really pulled out in the roadmaps now, because we need to move on from just looking at tank to wheel. And when you do that, you understand that actually it's not the engine that's all of the problems, if you see what I mean. As a machine, it works very well. Our main problem we're trying to or need to look at is where is the fuel that we're using coming from. And at the moment, on a fossil base, we're digging that carbon out of the ground and releasing it into the atmosphere as kind of new carbon. And so, you know, that's another area that we'll look at. But yeah, personally, I think that we can't afford to write the engine off just now. It's unreasonable to expect EVs and fuel cell vehicles to shoulder the entire burden of fixing the climate change problem in 10 to 15 years' time.
They're not dead yet.
They're not dead yet. I think one of the really important things, though, that's different about the roadmap this year is we've called out this section on sustainable fuels. Mm-hmm. And we felt that it was absolutely essential to pull this out and as a separate theme in order to do it justice and make sure it receives the attention it deserves, because the fuels can make a significant contribution to reducing greenhouse gas emissions when considered on a well-to-wheel and a life cycle basis. And you know, we feel that really had to be illustrated, because whilst we might be looking at new technology, we mustn't forget we have an existing fleet. More than 30 million vehicles on the road in the UK, more than 300 million vehicles in the EU. And you know, I think we'd all agree we can't afford to sit on our hands and do nothing about that fleet either. You know, so we really wanted to pull out the factor of these sustainable fuels and the contribution they can make.
One sustainable fuel in particular shows most promise? Is there a single one?
No, unfortunately not. That would make it a lot easier. They're going to change in their sort of source, and they're going to change over time, in my view. So in the short term, and addressing the sort of existing fleet that I mentioned, they need to be drop-in fuels, and we can increase the blend ratio. We don't have to go immediately for 100% replacement drop-in. We can actually blend that in over time as we build production volumes and things like that. But it's also foreseeable that, you know, we might be developing fuels and engines together to work perfectly in harmony for specific and bespoke applications. But the other aspect really is the different types of fuels. So it's fair to say, because of lack of availability of some, that the shorter term is likely to be bio-derived fuels, then moving through synthetics and e-fuels in the future. But you know, it's important to understand we can start making a difference to this now. The factors we need to think about, though, are the feedstocks. So where are the feedstocks coming from for all of these fuels? In biofuel terms, you know, first generation and the whole food versus fuel argument. So we need to move on to second generation, sometimes known as advanced biofuels. We need to think about where the hydrogen is coming from that we might be using in our internal combustion engine. Is it brown, blue, or green? We've got lots of work to do on the efficiency of the individual manufacturing processes, the resulting cost in the fuel, the availability of the fuel, and how much of the fleet we can address with that fuel. But the most important thing for the fuels side of it is the business case. How do we build a business case to get investment in that area? Currently, it's not recognised. As a consumer, we don't get a benefit from using a renewable fuel in our vehicle. An OEM doesn't see a benefit for supplying a vehicle that could run on a synthetic or renewable fuels because they have no control over what fuel. And the fuel industry, you know, doesn't see a benefit either. So we need to find a way of bringing this into perspective and giving it the sort of attention it deserves.
Right, and in 10 seconds, hydrogen. It would be remiss if we didn't ask. Hydrogen. Do you think it plays a strong role in on and off-road decarbonisation?
Yeah, absolutely. It's one of its big features is it's highly flammable, and that's great. We can run really lean, and that means that it burns, in inverted commas, with a cool flame, and it gives very, very low NOx. It's very tolerant on hydrogen purity, so you can run all sorts of things, so not quite as sensitive as like a PEM fuel cell. They're very cost-effective IC engines, so yeah, they should definitely be part of the mix.
Brilliant. Thank you, Steve. Thank you for sharing your insights and perspectives, and the continuing role of thermal propulsion systems on the road to net zero. Brilliant.
No problem.
So now joining us to share insight into lightweight vehicles and powertrain structures, Director of Composites UK, Chairman of the Automotive Composites Group and Composites Leadership Forum Automotive Division, that's a mouthful, Alan, and a Fellow of the IET and IKE, Alan Banks, UK Lightweight Innovations Manager for Ford. Nice to see you, Alan. How are you doing?
Very good. Thank you, Joe, for that wonderful introduction. It sounds quite clever, really. I'm quite impressed myself.
Fantastic. And just, I'm going to kick off with a question just around trends like so electrification and sort of ADAS and infotainment and all of these other sort of good things that are coming to our screens. How do you think they help the auto industry achieve weight reductions in CO2?
Yeah, clearly they're adding weight, so that's always an issue for automakers, especially if you look at commercial vehicles. I see commercial vehicles, which is really my forte, which is where that's going to have an issue. Bearing in mind that most people's driving licenses are capped at 3.5 ton. If you're not an old person like me, I can drive anything up to 7.5 ton. But for the youngsters among you, you're limited to 3.5 ton, which is a bit of a problem. So we see that for Ford anyway, we see that as a hybrid of material solution. It's unlikely that carbon on its own or any composite materials on its own are likely to be a viable solution due to their cost, certainly in the short term. So we see sort of a hybrid of materials, whether that's aluminium, a mixture of carbon, glass, or even lightweight steels. Steel is a good material, and that technology moves on all the time. Plus, I think it's important to look at the value equation especially for the lightweighting materials. If you're only looking at pure cost, I think you're always going to struggle trying to get those sort of composite materials, especially deployed into the marketplace. You need to start looking at sort of total cost of ownership rather than pure cost, and I think that's going to be the only way that we actually get that philosophy of the right material and putting it in the right place to really make sure that those materials get deployed.
And so increasing sort of the multi-material structures to sort of reduce weight, what are the implications for things like joining techniques and high-speed assembly?
Yeah, I mean, we're investigating quite a number of those. So clearly we need to look at some kind of sort of joining techniques with sort of structural adhesives that are coming sort of to the fore now with really good tack times, so we can get them through. There are issues around sort of putting composite materials through a paint plant because of the elevated temperatures going above the TGs, and obviously potentially affecting some of the adhesives and the resins that we use. But really, we at Ford are looking at if you put them in the right place and you're very clever about it. So, for instance, if you were going to put a hybrid material structure, and I'll just for use an example where you're going to weld it to an existing structure in your plant, potentially you would make that a lightweight steel that you're going to go and put in there, so you don't have to rip up your welding line, for instance. I think as long as you can get it in there from the start and it's part of your design, the hardest thing is taking an existing design and making it lightweight. When you do a new product, if you think of lightweighting and how you're going to bond it together or adhere it together, then you can actually sort of design these things in from the beginning.
Okay, no, great. So it's sort of common language now in the sort of the use of carbon fibre, and it's been a strong contender for lightweighting. What do you think needs to be done to make this sort of a more attractive, high volume and recyclable reality?
Yeah, carbon is clearly the holy grail for everyone working in lightweighting. It gives you everything you need. We think it's got a number of advantages. Not only, so is it a weight saving, which is really good, but if you're clever in the design, you can also get a part count reduction. So you can, for instance, you can compression mold or injection mold a single part in carbon that may be, sort of 10 parts when you fabricate it together. So there are clearly ways that you can do that. Recycling, I think for us in the automotive industry is quite key because we are the only ones that have an ELV directive. So we have to take care of that. But there's a lot of work going on in the background, and one of the things I'm very keen on when we do projects at Ford is to make sure that we do a life cycle analysis that includes recycling. In the UK, I think we have a significant advantage in as much as we've got 6 or 7 of the Formula One teams in the UK, and I think that kind of technology and the engineering that they generate does trickle down into the automotive sector. And I think for us, it's really good that we can see the benefits of that. So I think using things like unidirectional materials that are very expensive and then very difficult to sort of recycle. If we start to look at SMCs and EMCs, that can actually give us an advantage. Plus, when it comes to the performance aspects of the vehicle, for instance, so the fact that the parts are reusable, just by virtue of the fact that they live longer. If you've made a part in carbon, for instance, that could outlive the vehicle, and you could reuse that. You could use that in service. Sort of green recycling is something that I'm very interested in. I mean, there are companies all over the UK that are starting to look at sort of reused and recycled carbon fibre, and I'm very keen to get involved with those more. And I think from an OEM, I think we can help drive that. For instance, if we specify that the part must have a certain amount of recycled carbon in its makeup from the beginning, then that's going to force the tier ones and the material suppliers to actually take it seriously, rather than just assume that we want sort of virgin carbon.
Oh, great, thank you. And just a last question, if I may, just around the lightweighting roadmap. Do you see that being an opportunity to help industry and guide sort of through some of those challenges?
Yeah, absolutely. I mean, we do a lot of projects with government backing with Innovate UK and APC, and of course we use the roadmaps as our justification to do the innovation that we do. So without the roadmaps, it would be very difficult to justify why we're doing it. So the roadmaps are always very good. They're a real insight from us as to the way that the industry is moving forward, and as we've discussed earlier with all the other speakers as well, sort of EV propulsion in commercial vehicles is really going to need real innovation going forward. I personally feel that hydrogen is probably going to be the next sort of big thing. I think the jury's out as to whether or not sort of passenger vehicles and light commercial vehicles will need hydrogen. I think in my own head, where everything makes sense, it's very clear, for instance, that the heavy haulage and the marine and possibly the aviation industry are going to be reliant on hydrogen. Now, at the moment, hydrogen storage on vehicle has to be done with carbon fibre because there's no real alternative way of doing it. Now, how great is that? You've got a set of components that have to be made of carbon fibre, and you've got a whole section a whole section of the industry who are trying to lightweight as much as they can. And there's always been a bit of a stumbling block with regard to carbon in the past, because as soon as you mention composite materials, even though you said composite, people hear carbon and they just see the pound signs go up in front of their eyes, and they start to glaze over. When we have more sort of carbon out there in the industry, because we've had to have it because hydrogen is coming, that will really start the UK industry and the supply chain to really move forward. Because when you think about it, we've all got a common goal. We all want to reduce CO2 emissions. I think there are politicians out there who would argue against it. Fortunately, they've just been elected out. So I think it's very, very clear that this is coming. Everyone's got a common goal. And I mean, I've been fortunate enough to work all over the world, and there's no question in my mind that the UK is by far the best placed sort of country to take advantage of that. Sort of Boris just gave us a 2030 sort of deadline to reduce or to eliminate diesel and petrol vehicles from 2030, and I believe that's the most aggressive target for any country in the world. So we are absolutely best placed. We've got the right people, we've got the right universities, we've got the right tier ones, we've got the right OEMs. All we need is to really bring this together. And my roles, as you said, as Composites UK and as CLF chairman for Automotive, I really want to use 2021 to bring those together. I think this could be the year of UK innovation, to be honest, in this area.
Thank you. Thanks, Alan. That's brilliant. And thank you for a brilliant UK plug. Some really good food for thought on how not only how lightweighting plays a major role, but how the UK plays a major role in that transition to net zero. So thank you so much for joining us. Thanks, Alan.
Thank you.
Okay, we're now about to take a journey into the world of fuel cells, a brand new roadmap for this year. And to lead us on that journey, I'm delighted that we are joined by Chris Dudfield, Chief Technology Officer at Intelligent Energy. Now, Intelligent Energy is a world leader of PEM fuel cells, an engineering company based right here in the UK. And Chris, thank you so much, because I understand that your technical expertise has been absolutely invaluable in developing the new roadmaps. I'm delighted that you're able to join us. I'm going to go straight in with the first question. How do you think this new roadmap will help the industry?
Well, as you said, well, first of all, hi, and thanks for having me, and hi to everybody else in the virtual world. Yes, so I think as everybody knows, it's IE, and I bang on about it. So I'm a big fan of roadmaps, absolutely. I see them as an excellent tool in terms of certainly mapping out technology development across to market needs. So yes, to help out with Auto Council and APC on road mapping was a great honour. Really enjoyed it. I think it's been a really good process. What I'm really pleased with is now we actually have a hydrogen and fuel cell dedicated roadmap, has been referenced earlier, for our own. So previously, over many years, we've always kind of reached for the US DOE one or the Japanese NATO one, the FCHJ. You've got the UK one. So it's really good. I think the way it's laid out, it provides an excellent framework in terms of identifying the key targets all in one place, and gives a real good steer to industry, academia as well, with innovation. What are the key tasks that need to be doing, what we should be aiming for in terms of cost and performance metrics. And from my perspective, I think it should help government as well in terms of a steer towards what they should be funding, and what comes out of it. Is it real value for money in terms of moving us along the roadmap? And I think what a couple of the other speakers have said in terms of the roadmap as well, we should review them regularly, once a year, every couple of years. Don't leave them in the bottom drawer and then come back to them. I think, as Neville said, after 4 years, because they'll be out of date. So keep them current with industry needs, and keep them current with the technology development that we do in terms of certainly fuel cells and hydrogen storage as well. And I think another key one, as Alan just said, there's a lot of work going on in terms of hydrogen electrification in the other sectors now. And it would be a real shame if we can't interleave the auto roadmaps with, say, what they're doing with ATI, the electrification of the aero sector roadmaps, and some of the material science roadmaps. I think the Royce Institute rolled out roadmaps last year as well. So it could all fit together, and there could be great synergies there, right down into the supply chain, the technical development, and we will meet the targets that we need to across our various market sectors. So for me, yeah, big thumbs up.
Brilliant, thanks, Chris. And hydrogen has cropped up a lot today. So hydrogen fuel cells, a significant promise in terms of the future of net zero. How do you think that technology will compete with sort of that rapidly maturing battery offering?
Yes, we go around this a bit as well. So my own personal views, I don't think that they have to compete, or they're mutually exclusive. I think for certain applications, battery electric vehicles absolutely nailed on. I think for other applications, some of the heavy duty where the long range is needed, then I think fuel cells and hydrogen give a real advantage and should be strongly considered for those applications. Then, of course, in the middle, there's a mixture of both, and maybe there is a bit of competition there. But I think they can work equally well together. And from a fuel cell perspective, we need batteries. We need good battery technology on the vehicle. It has to start the fuel cell up. It has to start the balance of plant up, rather for the fuel cell. Even if we're using the fuel cell as primary power, as I said, we'll need batteries for startup, but also some of the peak shaving and the transients batteries, and then we go down into kind of where the range extenders and bigger batteries there. So all the developments in batteries actually help the fuel cell as we come down the cost curve, the better energy densities, the maturing of the technology in terms of durability. It always gives us a better overall fuel cell system product. So I don't think we need to compete necessarily. I think from a fuel cell perspective, another good lesson learned, though, if you can work closely with the battery technology, and we have done previously, is the battery guys have made great strides in terms of towards the gigafactories and how they automate the battery cells at low cost, and they scale up and towards almost lights out automation. The fuel cell industry, in particular PEM, needs to learn from that as well, and to use a lot of those techniques, because the PEM cells go together quite similar to the battery cells. So there's a lot of synergies there in terms of using the same guys who make the equipment for the assembly, or the QC checks that are put in place. So we can learn off each other, and again, be synergistic on that front. So I don't think it's exclusive, but I think the key challenges for the fuel cell industry when they do go up against batteries, as it were, is that we've got to meet the performance targets, we've got to come down the cost curve, and we've got to have hydrogen available when the customer needs it as well, because it's a key part to truly commercialising the technology. And I think another area of it is where the fuel cells can win out is some of the life cycle costs. The stack itself is pretty much recyclable. A lot of the balance of plant is as well. There is carbon fibers in there that we need to look at as well. But I know the battery guys, they've got their challenges that are looking at in terms of recyclability. Fuel cells have still got some work to do as well. So we need to address that and not lose sight of that just versus performance and cost.
Yeah, no, excellent. I think some of the, you mentioned there about the cost reductions and increased durability and sort of higher systems efficiency, I think are some of the areas that were brought out in the roadmaps.
Yeah, absolutely.
Yeah, I think in terms of what are the sort of key enablers to delivering these, do you think?
Yeah, I think there's across. I think in terms of, as everybody's got anywhere near fuel cell technologies, certainly PEM technology, it's platinum comes up, and the MEA, the membrane electrode assembly, is always a key component, both in terms of performance, efficiency, and cost. One of the cost components, obviously, the MEA is the platinum that's in there. So there's always a drive to reduce platinum. I think this is reflected really well on the roadmap in terms of trying to come down with the amount of platinum that's used. If you're still going to use it, just use small amounts, but get it in the right place. So there's certainly work for universities there and the MEA developers in industry. And then ultimately, can we get rid of platinum at all at the cathode? Interesting in question. I mean, the work's still ongoing. It's not just around the corner, but it's rightly on the roadmap as well. But I always say as well, it's not just about the material costs in the fuel cell. For example, the amount of platinum, a lot of the cost is embedded in the manufacture. So coming down the cost curve, we've really got to identify, design for manufacture, volume scale up, and take some of the manufacturing costs out. So it's not just about platinum. It's all about manufacturing the plates at cost, manufacturing the membrane at cost as well. And then there's a balance of plant as well, I think, in terms of efficiency. And I think this is where a lot of the UK supply chain can come in as well. So from a fuel cell perspective, we use obviously air blowers and compressors. They account for about 20%, 25% of the parasitics. So efficiency gains in design of compressors is key for us. Efficient thermal systems, taking the heat away, hitting the cost curves with automotive type radiator technology. But if we need to put coatings on, they've got to be low cost coatings onto the heat exchangers as well to deal with deionized water. And there's still a fair bit of work to do around power management, I think, as well, in terms of trying to source good DC-DC technology. There's not that much to choose from when you go out there from a fuel cell perspective. So widening that supply chain, better integration, shaving another % or 2% off the efficiency, it all helps. So there's plenty to go at, and I think all these key themes are really well caught on the roadmap. But I think we need to look at enable from a manufacturer and supply chain as much we can do in the UK against this roadmap. Create the jobs, create the capability. It is there. It just needs expanding out, I think. But it's very exciting times from a fuel cell and hydrogen perspective, certainly the last couple of 3 years, how it's developing and looking like where it's going to go now over the next 5, 10 years and beyond.
Brilliant. Thanks, Chris. And yeah, it's some exciting opportunities sort of coming forward. So thank you for closing out our fantastic panel session as well. Really good. So a huge virtual round of applause to all of our panelists today. Thanks to everybody for sharing and joining insights and perspectives, and really helping us to get into some more of the details and some of the challenges that we're facing as we tackle that global challenge of becoming net zero. Now we are going to move on to another topic that is truly transformative and game-changing. And here to talk us through how digitalisation will change the way we design, build and develop products and systems is an expert in digitalisation and business transformation who is working hard to establish the UK as a global leader in digital engineering, CEO of the Digital Engineering at the Institute of Digital Engineering, Bradley York-Biggs. Hi, Bradley.
Hi, wow, that's a hell of an introduction. Thanks, Joe. I never heard you do that quite that well before.
One time only.
Yeah. So no, thank you very much indeed for the introduction. And again, my job today is just to give you a bit of a tease, actually, not to sadly reveal a whole roadmap, but just to give you a bit of a progress update on where we are with developing a roadmap. So I have a few slides. As Joe said, I think the digitalization roadmap has been handled a little bit differently to the other roadmaps, because whilst the other roadmaps were a significant and excellent refresh of many of the technology roadmaps, digitalization over the last 5 years has moved on massively. So we've also really had to start from scratch. And many of the things that we understood 5 years ago have moved on, as obviously has the marketplace and indeed the world and society as a whole. So we started this in June last year, and we're just going to give you a bit of a flavor as to where we've got to. So timeline wise, we're a little bit behind where the APC team are. We have published our alpha release of the roadmap, which I'll show you a teaser of shortly. We published that just over a week ago to what we call the friends and family group. So key stakeholders, key very knowledgeable fact holders across the industry in certain aspects of digitalization. We're now receiving feedback just to make sure that we've understood and listened correctly. Our plan then is to present to the Auto Council Technology Group, Skills Group and Supply Chain Groups on the 26th of February. So if you're on one of those groups, or indeed if you're not, but you're interested in attending the beta release, then please get in touch through our website. And then our plan is to launch the full website in both printed or let's say digital form that you have the ability to download and look at on your computer, but also using an interactive website as well, which might be slightly more digestible, and we're going to do that towards the end of March. Just to stress, this is very much not just an IDE roadmap. We're orchestrating it and leading the activity, but we've been absolutely delighted by the input we've had from not just the automotive sector, but every other sector in giving us their opinions and views on technology, science, where it's heading, and fundamentally where it can allow us to transform the very capability of engineering and manufacturing across actually all sectors. So we've had 600 hours plus of interviews. We've had almost 11,000 post-it notes across 6 workshops. And like I said, what we have been delighted by is if there is any silver lining to COVID, it's been access to people that we've managed to create digitally, being able to get people on Zoom that we don't actually think we would have been able to access in the way that we've been able to if we'd been doing this 18 months ago, let's say. So I think that's been phenomenal, and very much we've been delighted by the response we've had. The roadmap will be split into 4 themes. Well, one is around digital engineering environment. So the technology itself, a lot of this is going to be centered around modeling and simulation, because we're talking about moving as much as we can out of the physical world into a trusted, correlated, appropriate fidelity digital world. That is because we're talking about engineering, is mainly around modeling and simulation capability. And that's in theme 1. Theme 2 is process and assurance. For me, digitalization isn't just about digitizing what we do today. Digitalization is around fundamentally looking at new ways of doing things. And one of those things that we within the IDE are leading is a piece of thought leadership on the very V model itself. What is the future process of engineering, and how should we be thinking about it differently? How do we genuinely get the time to develop a new product and launch to market to 2 years, not 4 in the car industry, for example? Coupled with that, very closely coupled, is how do we assure that product? That's becoming an ever increasingly complex challenge when we start looking at levels of autonomy and connectivity, and obviously the brave new world of electrification and, dare I say, hydrogen fuel cells. And part of that is, again, as we start to look at how we consume, use data across the broader infrastructure, let's say. 3, very importantly, is around co-creative ecosystem. How do we use science and technology to drive much better collaboration to the next level, both within our current organizations, but very much importantly with the future value chain for electrification and net zero suppliers. 4th, as I've always said, the easiest one to understand, probably the most difficult to actually deliver, is transform leadership, culture, skills and workforces. How do we get from where we are today in terms of capability to where we're going to need to be in the future to genuinely be relevant as global Britain in a very fierce global marketplace? Those are the 4 themes, and again, we'll go into more of those details when we see the roadmap. So this is all, sadly, I'm going to show you about the roadmap, but you can see those core themes on the left split into various swim lanes. The colours are still in discussion. I know they're a little bit bright and you probably had to turn down your screen brightness. They are still being developed as a design language, but in theory, those are the swim lanes, and we will show a bunch of chevrons that you can just about read behind the 3 horizons. So horizon 1 is 2025. That's a really important horizon because that's where we need to start drive immediate intervention if we're going to succeed. Horizon 3 is, as always, as Neville always very strongly talks about, is where we're actually trying to get to. And Horizon 2, always the most difficult horizon, what is that difficult period between what we can just about see that we need to deliver and where we actually are trying to get to longer term. So as I said, steps are, we are still receiving feedback from key fact holders on the alpha release. We then, very importantly, because we are very keen for this to be adopted, not just by the APC, but obviously by the Automotive Council, we need to present that to the Automotive Council for approval, sign off, validation on the 26th of February. And then you'll see a launch on the third week. I think we're looking at the 24th of March to do a full launch of the Digitalization Roadmap. And excitingly, we're going to try something different. We're not just launching a roadmap, we're going to launch an animated movie, relatively short movie, about 2.5, 3 minutes, but to couple and try to get people to more closely understand what digitalization is around as a journey and what the opportunity is that we have in the UK to deliver it. And that's it, Joe.
Brilliant. Thanks, Bradley. Thanks for sharing the advances you and the idea you've made towards embedding the potential of digitalisation, not only in this generation, but also in the next generation. So thank you so much for that. Thanks for sharing.
Thank you.
We have now heard from all of our panellists, and wow, what a fantastic session. Thank you to everybody for sharing so candidly the insights and also starting to understand some of the challenges that we face as we move towards net zero. So as promised, there will be time for a very limited number of questions, but please do keep posting them in the Q&A area, and we'll get to a few, and then we'll also come back to you. But now I would like to hand over to the CEO of the Advanced Propulsion Centre, Ian Constance, to give us a final roundup of today's session. Thanks, Ian.
Thank you, Joe. It's fantastic to be here. It's fantastic. So many people and so much expertise is on this call, and really that's been a theme of the roadmaps from the start. They are a terrific resource. The prior iterations of the roadmaps we know have been used extensively all around the world, in boardrooms of big and small companies, in the planning departments at universities and in government, to look at the future of where these technologies and where these sectors are going. And we think that these roadmaps really are a great next iteration, a great next step, and we'll continue that transition. It was great to hear Alan say that Ford absolutely use these roadmaps to help them justify where they're going with their technology planning, and we hear others saying similar things like that, and that really sort of justifies this work. And we know that they're copied as well. They've been copied across sectors, across industries, and by other nations, and of course other nations prepare their own as well and cross-reference as we do. But what it shows, the roadmap, what it shows all the people here and the expertise that you've just heard from, is just a snapshot of what goes into these roadmaps. They are really an exercise in collaboration and cooperation of all the expertise coming together in various rooms at various workshops to put their heads together to really look into the future and chart what their expectations are, and come to a consensus view of what is likely to happen and where the trajectories of these technologies are likely to go in the future. And that ability, that sense of being able to get in a room and collaborate with one another at such a high level, and sharing the knowledge in the spirit of moving the whole sector forward, moving this whole technology on, is really quite a unique thing in the UK, and something that we should be proud of. And it also it highlights the talent, the capability, and the knowledge, and the understanding of these technologies in these areas and these sectors that is so important. And we know that these documents and this knowledge going out into these boardrooms and universities and governments around the world really shine a light on some of the capabilities and talent that is here in the UK, and help people to understand that there is so much happening in the UK in technology development and the rollout of these technologies. And that gets them to consider the UK in their plans. Only last week, I was talking to a major OEM, a European OEM, who wants to do more research and development in the UK and wants to follow that up with more supply chain activity, which is great based on the last few years of Brexit, when people's plans have been kind of a bit on hold with the UK. But them saying that they want to do that. And the reason why they want to do it is because they love the speed, they love the agility, they love the can-do attitude, the ability to bring networks of people together to look at problems and to solve them in interesting and different ways. So these roadmaps really are a beacon of that, collaboration, that understanding, and that capability. And so really, thanks everybody who has contributed to the roadmaps. It's a lot of work. Everybody contributes around the industry and around academia voluntarily. They do it for free, which again shows a lot of commitment. That commitment and that voluntary contribution is backed up by a contribution from government in terms of cash, which helps us to do it and put it together, which again shows that ability of industry and government to come together in this space to do good things and to shine a light on what we're doing here. And so thank you to our government supporters, particularly in BEIS, who help us to put this together. My team at the APC, Dave and John Regnart and Bavik, who you've heard from earlier, are the engine room who get this thing going, and they are really to be thanked and much appreciated for their effort. And all the expertise that we've just heard from today in the room, appreciate you for coming along and providing those insights as well. So you know, I think we've heard some great things today. I think one of my favourites from Chris was let's make sure we don't keep these roadmaps in the bottom drawer. We have to make them real. We have to make them work. We have to get this technology moving. We have to be out there in the future. I think I think Neville made another point. I loved Alan Banks's point. This is the year of innovation. This is the year we're going to change everything. And you know, we really are at the heart of things here. We're out of a big change. For many years now, people have been saying, when's this EV zero carbon thing going to happen? When's it going to change? And we are really at the heart of that change now. So yes, Alan, let's look to the year of innovation. And with that, Joe, I think we should probably use the last few minutes to answer some of these excellent questions.
Great, thanks, Ian, and yeah, thanks to everybody. And if the panelists would like to join us back on the screen, hopefully you can all unmute and reveal yourselves again. We've got about 10 minutes left to just answer a few questions, and so I'll give you all a few minutes just to pop back on screen while we're waiting for the panelists to return. Just to let you know that the roadmaps are available on the APC website. Keep an eye out on social media as well. There will be sort of new notifications coming out for videos and other bits and pieces. Great, thank you for everybody coming back. I am going to take host's prerogative, and as we have only 10 minutes, I'm going to just ask a very quick question to all around life cycle analysis, and a question to everybody, I guess, and I'll sort of pop round in turn as I can see you all on my screens. Life cycle analysis, how big an impact do you think that's going to have on the development of technology as we go forward? I'm going to start with you, David, if that's okay. No, you sighed as well. I'm sorry.
That's no problem.
Oh no.
No, I mean, of course, we're looking at life cycle, and this is part of the standard design for us. So when we're looking at new components, and you know, we're looking at the switching technologies, one of the problems we have is taking what was an industrial part and making that and putting that into a power electronics. So a lot of the work we're doing is hardening this and finding better ways for industrialization. And I have to say, through the APC, we've been able to contact some really innovative UK companies for this. So yeah, we understand it, and it's just part of the standard design for us.
Great, thanks, David. Chris Dudfield.
Yeah, I think, as I said earlier, I think the fuel cells, I think they're in a reasonable position in terms of what goes on with recycling. The platinum as well, which is particularly expensive, but that can go around in terms of its own little virtual economy. I think we have to look outside the stack though as well. I think that's critical, right through to hydrogen storage in some of the type 4 lightweighted tanks. How do we deal with those at end of life? How we can recycle that? Through to typical balance of plant, the heat exchangers and compressors, everything. We shouldn't, from a fuel cell perspective, let's not just focus on the stack. It's the whole system we have to consider from a life cycle perspective.
Great, thanks, Chris. Ulrico.
Yeah, thank you, Joe. As I mentioned in the initial session, LCA is very important, particularly for batteries. And I think what we really need today is real data, reliable data, and really look at the numbers, because when you look at literature and so on, you'll always find a jungle of LCAs. So I think it will drive innovation. It's just that we need a uniform method to do it. And battery science is, as I mentioned before, is a very relevant topic, which should include all the steps, of course.
Great, thank you. Alex, how about you from your side?
I'll just start maybe, again, raise the flag for the UK, because I think on the recyclability side, there's a lot of good work when you look at the electrical machines, recycling of materials, including recycling of powder iron materials, as well as magnets. A lot of good work from Birmingham University on recycling of magnets. So yeah, it needs to be considered, of course, and I think for OEMs as well, when they look at the complete product, the recyclability of the product and the overall consideration of the life cycle is a key factor and a key part of the requirements of the design of the product.
Great, thank you. Thanks, Alex. Steve, how about from your side?
For me, it's all about where we're defining the system boundary. The life cycle is absolutely critical if you're trying to balance up what impact you're having in any particular technology solution. You've got to look at everything from the raw materials, the production, the in-use, and then the disposal, the recycling, the disposal or recycling, and that's the critical part. And if we choose to draw the system boundary around one part of that problem, we risk unforeseen consequences. And that's why I mentioned earlier on about we need to move away from tank to wheel. Just because we can't see those emissions doesn't mean they're not being created somewhere else. And so we have to be really careful. And that's where life cycle, which tries to take that big picture view, is really important. It's also really difficult. As Ulrico said, there's no fixed data sets really. Everybody's life cycle is dependent completely on the assumptions that they make. Everybody makes different assumptions, usually to perhaps influence the outcome of their LCA to make them look favourable, all that kind of stuff. But we should at least try.
Yeah, well, great. Thanks, Steve. Alan, and any thoughts from you? I know we talked a little bit about it as we were going through your session.
Yeah, I've just been nodding along to everybody else. Completely agree. I mean, whenever we do projects with Innovate UK and APC, as I mentioned, and one of the things I'm very clear with the teams that we collaborate with, that we're going to do a full sort of cradle to grave LCA, understanding everybody's comments that there isn't a single model, if you like, that we can all use to prove it. But I mean, I think from an automotive perspective and an OEM perspective, we could say we've got an electric vehicle, pat ourselves on the back, walk away that we don't have any tailpipe emissions. But if we've sort of generated more CO2 in the production of that vehicle that would ever be produced through the tailpipe in 10 years, then we've failed, and that doesn't do the world any good at all. One of the things I'm very keen to work on is the recycling aspects of all of the lightweighting stuff. I had a question in the chat about sort of what we do about recycling of materials, and there's a lot of work going on. I mean, we really don't have the answers, but everyone's working towards it. I think, in my experience, there's as much work going on in how we recycle composite materials than there is to the composite materials themselves. And I think it's very important that we do that. With automotive having the only ELV directive, I mean, yes, okay, aircraft do, but when they've got a 35 years sort of service period, that's, they can worry about that in 35 years time. Automotive doesn't, we don't have that, we don't have that luxury. So whilst we don't have the answers, I'm very keen to help Ford pursue them. We have a whole team in Ford who are looking forward to doing that, and I'm very keen to support them.
Great, thanks, Alan. Steve, did you?
I was just going to mention one thing, that Polestar did actually publish the an LCA of the Polestar 2 compared to a Volvo XC40. And I'd just like to say that it's laudable that they actually tried to do something to balance up and show how these things work. We just need to see more of that. Great.
No, fantastic. And just in the last few minutes, John Barwick, from a more holistic perspective across the whole roadmaps, LCA plays a major part in those. Do you see that continuing?
John, did you want to go?
Yeah, I can go. So, yeah, I think LCA from sort of materials refining and the mining side right through to end of life will just dictate different technology choices. So motors, it will dictate whether you get rid of magnets or not. Batteries, it may dictate whether we use different cell chemistries moving forward. Do we get rid of nickel and cobalt? But there's some positive news stories. I think if you look at the UK, the UK's energy system, I think we're decarbonising the quickest out of the G20, and all of these manufacturing processes will need low carbon energy, and that's decarbonising really quickly in the UK and across Europe. So as years go by, the electricity generation for EVs and for the production of components will go down as well. So I think there's some interesting things coming and positive movements. Barwick?
Yeah, thanks, John. So, Joe, yeah, good point. As a systemic aspect, actually, we've seen a lot of language change in the last year, Joe, within industry. Zero tailpipe is fine. We've got that covered, but LCA has become the new major story. LCA is a lot broader than just the product. LCA is all the way down to its materials, its construction, as John said, the energy of construction, so of its construction of vehicle. So the problem is now we're walking away from air quality and climate change into really understanding ecosystems and environmental aspects and impact. And that's the first time that we're seeing that rich debate. So we're now looking at Paris Agreement in a very different way, is to get that temperature right. It's no longer just only about CO2, it's also about other ecosystems on the planet as well. And that's a very, very rich and a robust debate that the automotive industry is finally getting into. Thanks.
Brilliant, thanks. Thanks, great to close out. So sadly, we are at the end of today's session. It's been absolutely fantastic. Thank you to everybody. Some really, really interesting insights, really useful. We've got a whole raft of questions, so hopefully we can catch up with you all after this and answer some of those for some of the team. But thank you to everybody who has joined us today. Thank you for everybody for asking questions and engaging and participating. And hopefully you can have an opportunity to download the roadmaps and get some more information. So we'll speak to you all soon. Thanks, everybody.
Thank you.
All right. Thank you.
Bye.
Bye.